Over the course of the past year, the global population has had to come to an eye-opening realization that we may have failed to consider. Just because something is too small to be seen doesn't mean that it can't have incredibly detrimental effects to our health and our lifestyles. Now, with the increased emergence of pathogens, many lacking current and effective treatment modalities, the understanding of how these pathogens are able to adapt, survive, and thrive despite our current treatments is paramount. Now, much like SARS-CoV-2, which causes COVID, Pseudomonas aeruginosa is specific in that it colonizes the lungs as well. Now, unlike COVID, Pseudomonas is a bacterium, one which is found already all throughout our bodies, even now as I give this talk to you guys. Now, typically it remains dormant until an injury or similar stress state allows it to become virulent and spread and colonize. And the cohorts that are most affected by this are those with cystic fibrosis. These individuals have a genetic mutation, which leads to a median life expectancy reduction and typically impaired lung function. Now, most of these patients subsequently pass away from Pseudomonas infection that's persistent all throughout their life because they never reach full elimination through any type of treatment. Now, this is due to Pseudomonas' inherent antimicrobial resistance, as well as its ability to acquire new resistance mechanisms, often brought on by the exposure to treatments. So our understanding of these mechanisms and which ones they're using is going to give us the best insight into being able to develop drugs and treatments for future use that could help to prevent or overcome these types of infections. So personally, what we've been doing is we've been collecting clinical isolates of Pseudomonas here locally in Tyler, as well as abroad in Baku, Azerbaijan, in order to assess their antimicrobial resistant properties and phenotypes. Now we're contrasting that with their individual gene variations to look at which mechanisms and how they're going about reaching these resistances. So identification of patterns that are overwhelming for all of these strains collected, regardless of location, are going to identify global patterns being used and therefore identify single drug targets or delivery possibly in which we can target to eliminate any resistant phenotype of Pseudomonas, as well as local patterns occurring just in those specific locations are going to give us insight into how clinical practice is driving those current resistance mechanisms and potentially predict future outcomes. So with this, we strive to prevent future outbreaks as well as protect the most vulnerable amongst us while providing a little peace of mind in a future moving forward. Thank you.